Press the record. So still have a minute or so before we get going. We have one of our Opus labs, the first Opus lab of the sequence. We bring them over to the observatory. So I'm going to try to be a little quiet because they're outside my door and the TAs are teaching and all that. How's everyone doing?
Too
Any
bad.
any adventures in Opus or MWU that anyone wants to share before we get going? Right. Well,
Yeah, my students just did trying to remember if it was Opus Lab 4 or 5. I need to go back and look, but some of the buttons have been moved. I think it was oh, I'll have to go back and look at my notes and let you know, but one of the buttons have been moved or something since
one of the
the
what
video was made.
has been moved? One of the
I think the aligner they were
Oh,
looking
one of
for
the
the
buttons. One of the buttons.
yeah.
Yeah, it could be particularly from previous Opus videos. In fact, the photometry, I may know what you're talking about. Yeah, and it pops up in Lab 5. I've been meaning to reshoot that video. Here, let me share my screen. Oh, here we go. Yeah. So it's this right here. Here's our photometry button. And since making the Opus videos, we've split it into a source catalog button where you can identify sources. You can see I've been playing with some Mars data in preparation for today. And so you select your sources here, and then we do the photometry here. So it's been split. And in the video, uh, it's not, it's a single thing. So yeah, that's something to keep in mind until I shoot a new one. All right, let's see here. Slide this window over. So over here. Okay, and I'll spread you all out. All right. Hey, I think we have everyone here. As I was saying, as people are coming in the room, we have an Opus lab going on right outside the door here, and TAs are teaching and whatnot. So I'm going to try to keep my voice down a little bit. But today, unless anyone has any other adventures in Opus or MW experiences to share, going once, twice, three times. Okay. Uh, Today we'll continue on with the MW sequence. Um, the last two times we've met twice. The first time we tried the moon, ran into some server problems and all that, but the server hadn't been rebooted for a while. Vladimir did that, and we tried it again last week, and it worked out really well. We all got really nice moon images for those of you who were here, and if you weren't here, you can go check the videos. I've shared the link on the thread. So that's Module 1A. Uh, Today, we'll process some planetary data. This is actually Module 1D. Um, the order in which you do these can be moved around a little bit. And that's just the order I'm using this semester. I think the reason I picked this order, I started with the moon because the moon was near full phase. And then I had them collect the optical planets data because Mars was the closest approach, and I want to be as close to that as possible. So because Mars, it shrinks pretty quickly in its angular diameter. And my students have also collected the 1B, 1C radio data. Half of them are doing the radio moon and half are doing radio Jupiter. And that data is being collected right now. But it looks like the 1D optical planet data sets have come back first. And so that's what we're going to be doing this week. And we'll probably divide this over 2 weeks. Uh, if you read the 1D module, you'll see it introduces them to different color combination techniques. One is the percentile technique, which basically, you'll set some percentile, like the bottom 1% of my image, make that black, the top 0.1% of my image, make that white. and it stretches the red, the green, and blue based on those percentiles. And as long as the brightest thing in your image is white, then percentile stretching works really well. And so we'll do that today. It's the easiest color combination technique, so we'll start with that. Well, if there's time, we'll also do. Let me back up. So there are three techniques. One is the percentile, which is the easiest. The second technique is the photometric calibration, where you use background stars. And this is the technique we'll use throughout the rest of the MW sequence, but we're building up to it starting with planets. With Uranus and Neptune, you should get enough background stars that you can calibrate to photometric catalogs. And so we'll do that next week. I still have to play with those data sets and make sure it works this semester. And then the third technique is if neither of those techniques work, you can just adjust things manually. And Mars is a good example of that. Okay, so let's start with Jupiter and Saturn. Let me put this in the chat here. Everyone should go here. This is my class's observing log. Each team has a different tab where they're putting in their observations as they submit them. And the Sherpas and myself, we're here on the front tab. So that's where we're going to be today. And I just spent the morning processing all my planetary stuff. I did a little bit of it a few weeks ago, just to refresh my memory. And we've collected a lot of data recently, and I processed all but one of the data sets because I ran out of time. So we're all going to pick a data set. Let me shrink this a little bit, see if I can get the whole thing in here. So you can see some lunar data sets. Okay. So everyone pick a Jupiter or a Saturn data set. And oops, I don't want to slide that around. Let me highlight the Jupiters. And before you, let me tell you about the Jupiter data set. So I've gone through these 6 data sets. The 2 in the middle are saturated. We had to swap out filter wheel partway through the week, and the new filters had different throughputs, and it was a bit of a mess because my students had all submitted their observations. On Tuesday, the filter wheel died, put a new filter wheel in there. The observations went through, and things were saturated in at least one filter. So I went through and re-observed all the planets and came up with new exposure times. They're in the lab now. And we reshot, and everything seemed to work out fine. So these first 2 data sets are from before we had the filter wheel problem, and both turned out good. One has only 3 of the moons, one has 2 of the moons, and one came out, but both came out yellow. So it's a little bit off. And I think the orientation of the cameras was still incorrect because this was right after the build trip in mid-January. And these are 2 recent data sets, and they both look great. And you can see all 4 moons, and Io is yellow. And the only sad thing about these is the red spot's not in the image. Red spots in these, not in these, but these have more moons. Anyway, if you're going to do Jupiter, pick one of those 4. And if you're going to do Saturn, I did 2 of them, one early on, and it just didn't come out looking good. I mean, Saturn's really close to the sun, and I'm telling Skynet to observe all the way down to 10 degrees above the horizon, and, we're really pushing it. But this second one here came out really nice. I just processed it. It has 6 moons. Titan's yellow. So let's make sure at least one of you's doing Saturn. Raise your hand if you're going to do Saturn. Okay, we've got a couple Saturns. The rest of you will do one of the Jupiters, one of those 4 good ones. Okay. So to find the data set, we're going to go to Afterglow. First of all, clear out anything you have in the workbench. Clean slate's always good for processing these data sets. Now, I should say these were all taken with prompt 5 and prompt 6. These are all 1K by 1K chips. So the data sets are small, they load quickly, that's nice. The pixels are 0.6 arc seconds. Prompt 6 has slightly smaller pixels, and so you can get a nicer image if you use prompt 6. but they are larger format, 2K by 2K, so it's a slower process. And generally, we try to avoid planets on prompt 6, just because that's one of the astrophotography telescopes. And bright planets leave that residual ghost image that can screw up the astrophotography stuff. That being said, Tad Thurston, I don't know if he's in the group, but yeah, he can't make this time slot, but he emailed me his Jupiter picture that he did with prompt 6, and it looks really nice. And you do see a little bit, there's, the pixels are a little bit smaller. You do see a little bit more detail than what we'll get out of prompt 5 and prompt 2. But that's just setting some expectation there for you. Okay, so to get to your data set, it's open files. You're going to files, and then mine's stuck. Let me try again. Okay, Skynet, collaboration. All the education stuff is in Project Intro Astro. So if you filter on project, it's there. I took these with the MWU group account. So filter on MWU just by itself, it's there. Filter on my name, Reichert. It's there. You can see this is the information that's given. The group. Well, I didn't give the collaboration, but the group, the username, now the observation name is next. So this is all stuff that I've observed. I'm going to click on last modified. There we go. Last modified, pointing down, we'll put the most recent stuff up here at the top. And I'm going to filter on, I'm going to do one of the Jupiter ones. And let's see, which one will I do? I'll do one with the moons here. I'll do this one right here, the prompt 2 one. Let's see, that's 7, 8. Let's see. Tried to filter on Jupiter, didn't take. Let me try again. Jupiter. Prompt 2. Why is my filter not taken? I'll give it a second here to reset. I believe I said, what was it called? One that ends in 7, 8 for me. Oh, it's right here. Now, before I load everything in, one thing you should do is check the observation on the Skynet page. And so that's this one. I'm just going to open it up. Now, I've already run this. I know it's good. But kind of the things you want to look for, make sure your target's actually there. You weren't clouded out. And make sure they were all taken close together in time, that there wasn't a big time gap. So the first one here is January 24th at 1:19. And the last one, if I scroll down, January 24th at 1:23. So these were all taken within 4 minutes. There's no large time gap. There is, Jupiter rotates and the moons move, and you'll get a blurry image or multiple moons. But I like to just skim through them all real quick, and they all look good, nothing saturated. So, but I've already checked these. So once you've done that, I'm going to keep going into reduced here. Select them all and open them. Again, these are the 1K by 1Ks. They should load pretty quick, which is good for this analysis, because we will be hopping through each individual image. Now, with the moon, we did feature-based alignment. The planets are just too small for feature-based algorithms to work. So we're going to do kind of a manual. There are no background stars either. And so we're going to do, if we had background stars, we could align using them. We're going to do a manual alignment, a 1-point manual alignment. Okay. So mine are all up. Mine are all in. Does everyone have their images in?
Almost.
Almost. I'll wait for you. When it comes in, looks pretty yucky, but we didn't really saturate on Jupiter. That's just the brightness and the default brightness and contrast scaling. Okay.
I'm in.
Anyone else still loading? Okay. So first thing we want to do, maybe go to the first one in your list. Okay, here it is. And go up to the display settings tab and hit the bright target brightness and contrast preset. So this is H alpha, that's my red filter. I can see the banded structure and all that. Okay, you can see a little bit of a moon here too. And to make this real easy, we're gonna hop from image to image. Zoom in on your world, and then come over here to settings. And yours probably looks like this. If you sync display settings, then that will change them all to whatever display setting you're using here. You won't have to do it for each one individually. And if you sync orientation and put it in pixel mode, because we don't have sky coordinates on these images, there are no background stars, put it in pixel mode, that means as we hop from image to image, it will go straight to the same zoom in that you have. The planet may move around a little bit just because it does from image to image, but you'll be zoomed in really close. So sync orientation pixel and sync display. Then go back, and you can see if you go to the next one, which you can do by clicking on it, it'll load in here, and it will zoom in, and I'm there. Now, a nice little shortcut to know about is shift left arrow and shift right arrow. So I just went left arrow, right arrow. I'll do right arrow again. This one's not loaded yet, but it's about to load. So using the shift arrows, I can bounce through them real quick once they're loaded. Okay, now go back to your first one. And is everyone with me? You got everything synced up and zoomed in? Okay. Now, with these, we're not going to do cosmetic correction. The cosmetic correction algorithm doesn't do great with planets, at least not with a whole bunch of planets. With a single image, yeah, it works, but with a whole bunch, there's some technical things, and so we're going to remove defects a different way. So we get to skip cosmetic correction, and we're going to start working on alignment. So the first thing we want to do is we're going to go to the source catalog tab, the star right here. Now, if you have anything in here from previous work, you can check by turning include sources on from other files. If anything's lit up, just empty it out. Probably nothing is unless you've done this before. But once you're done doing the first one, it will be. So when you do the second one, include everything, empty it out, and then turn the include off. Make sure centroid clicks is turned on and planetary centroiding, because centroiding with the planet is a different algorithm than centroiding with the star. Centroiding with the star is a center of mass algorithm. With the planets, we have to actually detect the edge. We don't want to use center of mass because some of these bands are brighter than others, but it's different in different filters. So you'd have different centers of mass and different filters. And so it's a different edge detection algorithm. And Josh and I work really hard on it. It's homegrown, and it works almost all the time. So all you have to do is go near the center. You don't even have to be exactly on the center. Technically, you could be anywhere within the disk and it works, but the closer you are, the less likely it's going to trip up. And we'll click and then shift arrow and do the next one. And there are 30 of these, 10 in each filter. Though Saturn actually has more because Saturn has some faint moons. Jupiter only has bright moons. Saturn has faint moons. And so I think there could be, we try to observe 90 of those. I don't think we got them all on that Saturn observation because it's close to the sun. We click through. It's a little bit tedious, but it's not terrible. And if it looks like it, see, now I just switched filters. I'm in the O3 filter. It looks different. If it looks like it puts it in the wrong place, you can always come over here, delete it, get closer to the center, try again. Should be careful not to double click or zero click. If you miss one, then when we try to merge them all, letting Afterglow know that all these centroids are of the same object, they'll get confused. If you double click when we try to align them, it will get confused because it won't know which centroid to align to. Okay, I think I'm onto my U-band now. See how the coloration changes from filter to filter?
Dan, I got down like halfway through and now I'm not getting clicks anymore. I don't know if I'm doing something stupid that I should be able to reset this or
Did you start at the top?
yeah, I started at the top and but for the first 15 I have the plus right in the middle
And
like
then it
you
stopped.
have. And then
I've seen that bug. I encountered it once or twice today where I click on it and I can't get anything.
yeah, do you have a suggestion on should I just
Yeah, just
clear out all the files
refresh
and
the
reset?
browser.
The same thing happened to me. I just went to the files panel and just started clicking the images and swapped to a new image, and then I seem to be able to do the centroid clicks, but the shift arrow doesn't seem to be working.
Okay.
Well, okay. Well, I'll figure something out. Thank you.
Let me see where I am because mine kind of jammed up too. Got a couple to go. For some reason, it got confused and it's reset my brightness and contrast.
Yeah, I saw the same thing.
Okay, that's where I left off. Okay, I think that was the last one. So once you have them all, just check them, make sure they all look reasonable. Like that one looked like it may have seems a little off. I'm gonna try that one again. Yeah, I don't know. We'll see. Yeah, it's having a hard time with this one. That looks better. And after we align them, it'll be real clear if any of them missed. But it's real nice after you have them all in. It's almost like you can make a movie just by scrolling through. So I'll pause and let everyone get to this point. The Saturn people are probably still clicking away because I think they have 50, instead of 30, I think they have 50 images, something like that. Maybe 70. They didn't get all 90. Yeah, with Saturn, we do more to bring out those fainter moons, looking for color. Just detecting them is one thing. You can do that in a single image, but if you want to try to get the color, you really need to collect more data. Nice thing is once you get past this part, the rest is super fast. This is the slow part. And while you're doing it, I'll just describe. People who do planetary astrophotography, they do this very different. They have video cameras on their telescopes. They image at video rates. They have software that goes through and finds the best n%, where n can be quite small, discards all the rest and keeps the best, combines them. And basically, you're looking for a handful of images where the atmosphere was just perfect and not distorting. And they derotate. If you're doing one with Jupiter's red spot, you'll see it. After we align, we'll hop through them. You'll see it moving. They do all these nice things, and you end up with a picture that looks like it was taken from space. We're not set up with that kind of equipment. We don't have the video cameras. because there's really no other professional use for it. A few, but not enough to equip the professional Skynet telescopes with that technology just for an educational activity. So we're going to have atmosphere blurred images, but we're going for the colors. MWU is about color interpretation. Saturn folks, are you there? Matt is.
Yeah,
And
I'm
Gene,
good.
I see the beads of sweat going down his forehead. He's
I think I just got the
Well,
last one.
it stopped being zoomed in the same, so I go down a few, and then it goes back to the small image. You got to zoom in and find it again, and
yeah,
didn't
it's
sync 'em
sometimes
all.
for whatever reason I don't quite understand, loses track of the default, and then you got to kind of go back up to display setting and reset it. Okay, so now that we've done that, turn include sources from other files on, and you'll see all your centroids together. Select them all and hit the merge button. You can call it whatever you want. To either use the first number by default, or you can call it like the name of the planet and merge. Now, if you missed one, you may encounter a problem there. Or if you got two on one, you can encounter a problem. I haven't done that mistake this year, so I'm trying to remember. Go ahead.
Can you go through that step one more time?
Yep. So you include sources from other files. You turn it on, select all, and they'll all light up. You press this merge button and give it a label, or you can just use the default label and merge them. Then you see in the table, they all have the same ID. And what we've done is we've told Afterglow that all those centroids that we just did, they're the same object. It now knows that's all the same thing. So when we go to, because you can imagine, if you want to be really precise, you could do planetary aligning on Jupiter, but also go and centroid on moons. And you could have, suppose you did 4 moons and Jupiter, you could do a 5-point alignment. Anyway, so that
Dan, if you were doing that, you'd go through and do what you just did, and then you'd clear all those and go back to the moon and go through the same process with the moon, with the same moon.
You wouldn't clear them. You'd have to actually, if you clear it, it would forget. You go through them all again, do the moon, and then when you merge, you'd only merge the moon ones, the same moon. If you want to do another moon, just that. So in that case, select all is not going to work. You're going to have to go through and select your 30.
Okay, that helps though. That's what I was curious about, was how to select the ones. So you'll just have to go through.
But I don't think it really helps that much. These are pretty rectilinear. 1-point alignment's good. So
that merge button, is that one lower left there?
This right here.
Mine's grayed out.
So did you press include sources from other files?
Yes.
Did you select them all?
Yes.
And it's grayed out. That means one of your images has 2 centers, I think.
Dang it, man.
So,
Okay.
hop through it. I'll let
it.
you do it. We won't wait for you, but you hop through. Don't turn this off again. And hop through, and you'll find the one that has only one, or it has more than one.
Okay.
And delete them and redo it. Okay, but for the rest of you, you can go down to the aligner. It's under the cleaning magic wand. So you go down to the aligner. We're going to select all the images to align. And we're not in mosaic mode. That was just for the moon. We need a reference image. It could be any one of them. Everything else would be shifted to it. And under source, the mode will be sources manual. You don't have to worry about any of this stuff. You just go down to manual align sources and click on your merge source. You select them all, and they all have this one. As long as you got one click in each image and you merged all those images, then all these images have this source in common. And it doesn't really matter if you enable rotation, scale, or skew. With only a single reference point, it will just ignore that. You need 2 to rotate, 3 points to also scale, 4 points to also skew. Okay, and crop should be on. Everyone has this. And just submit it.
So when you aligned them, did that make a new file? It looks like you're
Yes. And so,
using it looks like you're on one of the original ones.
yeah, I just, here we go. My job just, as soon as it finished processing, it does update each file.
Okay.
So we marked a source on each. That didn't change them. We came down here and told it to align using that source.
Oh, I
If
see.
it
Okay.
finishes, then they've all been shifted and recropped. And kind of what I'd like to do is just check it. And so I come up to the first, and you got to go through this process of reloading them. And sometimes it, like right now, there we go. Maybe a little slow. It brings up the original, and as soon as it can, it refreshes it. Maybe because we're all hitting at the same time, or sometimes you just got to reload the browser to get it thinking. Okay, so let me try again. See, it's the old one and it's reloading. Old one, reloading. You don't always have to do this, but it's kind of a fun exercise. Particularly if you're zoomed in, doesn't have to load everything in the image. So it can be fairly quick. Plugging through, making sure I got them all.
So Dan, should they all be aligned by pixel now or by sky if we went over to the little
They're
thing
aligned by pixel. We don't have sky coordinates on them. But once you have them all in, you can hop through them and they should all be aligned. There we go. I got mine all in. So it's like a little movie. And this one doesn't have the red spot, but if you have the red spot, you can actually see it rotating, which is kind of cool. It's also going to blur your image a little bit, but I feel like I get a little shift there. Some of my U-band ones hopped around a little bit. See that? It could just be the atmosphere pushing them around, or maybe it had a hard time with the centroid. I'm going to run with it though. All the reds, the greens. Oops. I guess I had another that hadn't loaded yet. See how my blue ones are bouncing around a little bit? So I have a few bad alignments. Guess my last couple aren't loading in for whatever reason. Anyway, I'm going to run with it. Okay, and so it's real simple. We go to the stacker. I'm going to filter on H alpha. Select all. Now, a difference from the moon mosaic, we are going to do some outlier rejection. We didn't have the cleaning algorithm to get rid of the bad pixels, but we do have like 10 images deep. And so we could do traditional bad pixel rejection. Now that they've all been aligned to the image, the bad pixels have been moved around. So at any given pixel in the image, maybe 9 of them are good, but the 10th one is a bad pixel. And so we can use the fact that we have 10 points here. We can find out which ones are not like the other. So rejection, you want to switch that to Chauvenet. And you turn on the low rejection and the high rejection by setting these both to 1. So it's kind of like it's taking, at each point, it's taking a mean and standard deviation. and saying, are any of these things too many standard deviations away? And too many depends on how many images you have. That's what the Chauvenet criteria does. It's sigma clipping. This is sigma clipping, but instead of just picking 2 sigma, 3 sigma randomly, like if you have a small number of images, you don't expect a 5 sigma deviation. But if you have a million images, you're going to have lots of 5 sigma deviations. So what is actually an outlier depends on how many images you have. Chauvenet's criteria is a simple way to know that. So we're going to do that and make sure propagate mask is on. That will make sure that the cropping is the same for everything. But all the equalization, that was just for mosaics, that should all be off. And this will run super fast, unlike with the mosaics. So got the H alpha going. Going to filter on O3. Oops, someone moved. Chauvenet 1-1. Propagate mask, submit. Filter on U. Submit. Then take those out and search on the word stack. They're probably all done by now. Saturn ones may be a little bit slower because you have more images. So I'm just going to check them. There's my combined red. I'll color it red. O3 is my green. I color it green. U is my blue. Even though it was hopping around a little bit, it looks okay. I'm going to color it blue. Going to click on all 3 and group them just like we've done before. Then you got to get rid of the word stack and go find your group. And I'll pause and let everyone get here. Getting some head nods, some happy head nods. I assume success.
Oh, that's your image.
Oh, my image.
It looks
Okay.
awesome. I'm still working on mine.
Jupiter's gonna be the best looking one, right? Because it's using the most pixels. And again, if you use prompt 6, it probably looks even better. Here's Tad Thurston's. I feel like I can see a little bit more detail in here with the slightly smaller pixels, but it's close. Again, I'd rather the students do this on P5 and P2 than to use P6, so we don't mess up other people's astrophotography, deep sky astrophotography. But I'll give you a chance, everyone a chance to get here. Saturn doesn't look super impressive right now. The rings edge on, but it'll be okay. Then I'll show you how to link this and adjust colors and bring out moons and all that.
Dan, mine came up just yellow.
Did you make sure all 3 are colored? Maybe your blue one didn't get colored.
Yeah, they're all colored.
Hmm.
When I click each, I've got a green and I got the red H alpha. Yes.
Okay,
Oh,
share
there
your
we
screen.
go. There we go. I clicked on it again and it disappeared.
Okay, maybe it was still coloring one of them behind the scenes. Did everyone get something like this? Are you still cranking? Who needs more time? Once you practice this and get good at it, it's 10 minutes to do one of these. Saturn's a little bit longer. Okay. Anyone else? Need more time? Okay, now let me show you what to do with this. Go up to the Display Settings tab. This one right here. And we're going to link all layers percentile. And it won't change anything because that's kind of the default. Basically, each image has been scaled using percentile, but they're not linked until you do that. Now, what do I mean by percentile? If you look down here, background level 10%, saturation level 99.999. Those are the defaults for bright target with the linear stretch mode. That means in each frame, like here in the red frame, it took the dimmest 10% of pixels, and they're all black, and that's the 0 level. And it took the brightest 0.001% of pixels and made them all white, or all red in this case, and that's the high level. And scaling each one separately. Now, if the brightest thing in your image is white, it's going to be okay. And with Jupiter, that usually works. With Venus, it works. With Saturn, it usually works. Those are the three where percentile scaling works really well. Now, once they're linked, like I linked them all to the H alpha layer, I can change it. Now, with planets, the linear stretch mode and the bright target preset work really well if you're just looking at the planets and not the moons. You know, you could play games like, well, let's just play games to go straight to the moons. Normally with faint stuff in astrophotography, we'll try the midtone, though often with the planets, you have to fiddle around with different stretch modes till you find one that works. Let's try the midtone. And once you hit it, hit the default. That will establish it for all of them. And then after you've done that, this is too bright, so I'm going to increase the midtone level. Maybe I'll make it 99, 99.5. That's pretty good. I want to make sure I'm not saturating on my moons. That's pretty, like if I go to 99.4, still not saturating on the moons. That's pretty good. But I don't like that nasty glow, so I'm going to up it a little bit. And you can also increase the background. It doesn't really matter that much with these here. So we saw the planet, but now let me give it a rotation here. And I think, trying to remember which way I'd need to flip it, but I'll bring up Stellarium in a second. Which one of these is Io? We got Moon 1, Moon 2, Moon 3.
Closest
Yep.
and reddest.
Yep. It's yellow. And you can really see it. Now we have a little bit of achromaticity, I don't know, because probably the moons were moving a bit as you know, our images were taken. Now let's check it. I don't know why my mouse is sticking here. Okay. I'll go to Stellarium. Bring that up in a second. Click on any of the layers and hit information because you'll have a timestamp. If you load up Stellarium, I have it here. The first thing you want to do is come over to the location tab. The location doesn't really matter. In fact, I'll just reload Stellarium so you can see it from the beginning. Function F11 to take it out of full screen. Location, again, doesn't matter, but you want to change the time zone to UTC 0, essentially Greenwich Mean Time, because those are the times that are right here, GMT. So custom time zone, set it to UTC 0. We do this in the Opus Labs too. You turn off the ground, turn off the sky, and put it in equatorial mode by hitting the telescope icon. And let's go to Jupiter. sometimes takes a, if you go too fast, you may have a hard time loading. There it is. Okay, and we got to get the timestamp right. So let's see, this was taken January 24th at 1:20. See, did I orient correctly? No, I need to flip it. Mirror. And there we go. That's the correct orientation.
Dan, real quick, the in the metadata, in the file info, you've got the time. Is that, I guess there's a start time and a center time. Is that,
Yeah, you probably
is it
want to
like
use,
coming from multiple images? Is that what we're doing? Or how is it deciding what the
yeah.
time is?
Looking at that, ideally, if we were combining multiple images, it would take it from the beginning and the end. So if it's just a single image, one is the start of the exposure and one's the midpoint of the exposure. Once you combine them, I think it's probably just taking the information from the first thing in the list.
Okay.
It shouldn't really matter. These are very short exposures.
Sure, for these, that doesn't matter. I just, yeah, sort of general question.
I need to talk with Vladimir about what's the best information to show for stacking images from different times. But these were all taken within a couple minutes, and so you can get it good to a couple minutes. I'll put the pretty picture back, the colorful one back up. So a couple things you can do here. We have a labeling feature, custom markers here. You can turn centroiding on and you can label things if you want. You know, you can imagine labeling all the moons, and then if you do the snapshot, it dumps out just the screen view here with your labels, but it's not going to give you every single pixel. It's just whatever's in the screen. But that's the only way to keep the labels. Or we can dump out the whole image. That's the second button here. Every single pixel, and it does sub-pixel interpolation. So what you saw as pixelated data here, right? You see the pixelization. It does sub-pixel interpolation when it creates the JPEG. It's not increasing resolution, but it does give you a smoother look.
Hey, Dan, this came up in the Opus Lab the other day. Is there any way, it doesn't look like it, to increase the font size of your labels? Because sometimes if you have it on a larger field of view, you can't quite see the names.
Radius, label radius. Yeah, we don't have label font size, and I
That's
agree.
okay.
That's something that shouldn't be hard to add. Next time Josh is on Afterglow, which is probably going to be better part of a year, remind me then.
All right. Thank you.
Okay, so we have. Does anyone have a anything to show? You did different ones. All the Jupiter ones probably came out like this. I should say if I go back here, bright target. I'm going to put it back in linear. Dump this out, full pixel set. You know, it does the interpolation. Looks pretty good. The colors are pretty good. Does anyone have something to show? Got like a Saturn moon one? Anyone get to the moons of Saturn?
Yeah, I can show you what I have. Can you share?
Yeah, let me stop share. Okay, and okay, it's set up to share.
Here we go. So Oh, you know what? Let me reshare my whole screen so I can show you the stellarium. So when I go to stellarium, I get these moons. Can you see that?
Yep.
Okay. So, and then you can definitely, oops, that was a mistake.
If I had to
Sorry about
guess,
that.
your stellarium's probably not in UTC 0 because there
Oh, it is though.
is it? Okay.
I thought it was.
Oh, it
Um,
is. It is. Okay.
location, yeah.
Okay. I'm trying to figure out the moons do look slightly differently placed than in the image.
Do you think this is a moon here?
Yeah. Um,
Hmm.
let me see your timestamp. Click on one of the layers.
Oh, I did not turn it on equatorial. Thank you, David.
I don't think that's it though. Click on like your blue, green, or red layer and let me look at the actual time and turn
Oh,
in.
sorry, yeah.
Yep. So
123.
123,046. Okay, let's look at stellarium and your time. 123.
Uh,
When you cross
thank
the,
you.
yep.
Yeah.
Let's take a look. You'll have to search on Saturn again. There it is.
Ah, sorry.
There you go. That's a perfect match to your.
I was off by a day. I just clicked the wrong thing. Thank
Yeah.
you.
So you got 6 moons there, and you can imagine spending time. Go down on Stellarium and hit the telescope button at the bottom. Yeah, 2, 3 to the left, 7 to the left, your other left. One
This
more.
one?
Yep. That puts in, yep, right there. Go ahead. Yep. Now it's in equatorial mode. Should be aligned with your image, except maybe a rotation or a flip.
Yeah,
Yeah.
it's a flip.
Yeah, with yours. So if you go to the display button, yeah, and scroll to the bottom, it's a mirror image. Okay, that should be a perfect match to what you have in Stellarium.
Sweet. Yes, sir.
So you got 6 moons,
Yep.
and maybe it's a little hard to see. Increase your mid-tone level a little bit more, maybe 99.8. See how Titan is oranger than the other moons?
Mm-hmm.
And it should be, right?
Yeah.
Because of its orangish atmosphere.
Sweet. Thank you.
So good. No, thank you for doing Saturn. So we had another case to look at. So,
Dan,
yeah, go
when
ahead.
I did my stacking, I got some semicircles off to the edges that are white.
Yeah, show me. Probably what happened is you had some misalignments.
Okay, so so the planet's here,
No,
and then I got these big circle. Can you see that?
no, you're not sharing
Oh,
it.
okay.
Oh, it's a loading issue. Just refresh the browser.
Okay.
Now with this one here, or just leave it alone for the time being. You haven't colored your layers yet, have you?
Yes, I did.
Okay. Um, go to color composite tools. Oh, I see. You're in midtone.
Yes.
Yeah, yeah, that's right. Because you're looking at the moons. You're looking at the moons. Yeah.
Yeah, but these the off to the side here are these strange white circles, and it's in every image.
Yeah, it's a loading thing. If you press the button at the bottom to export it, they won't be there.
Okay.
Or if you reload the browser, they'll go away, hopefully. But yeah, go ahead and give it a try. Press that the button at the bottom next to the camera. Yeah, that one right there. And then show us what comes out.
Okay.
Is it all good?
Yeah.
Okay. All right. So let's see. I was going to also run through Mars or Venus. Venus, you do it pretty much the same way. I'll give you a couple hints in the final few minutes since we won't have time to run through them. The maybe Mars I'll show you next time because it's special. But Venus, let me highlight the Venus ones here. Two were bad, but I had a good one. This is before the filter change. After the filter change, we now saturate in H alpha. It's very sad. Even at the shortest exposure time, there are different H alpha filters, H alpha 3, 5, and 7. They're different widths, I think nanometers, 3 nanometers, 5 nanometers, and 7 nanometers. And the new one's a 5. I guess the old one was a 3. And Venus is so bright. And so with the greater width, we now saturate in the red filter. But what you can do, I wish I had a demo image up here. I guess I can show you with Jupiter. It won't look right with Jupiter. But suppose this were Venus and my red saturated. I could just turn it off.
Dan, you're not sharing your screen.
Thank you. Thank you. Thank you. It's back on. So if you want to try Venus, I was saying we have a good one here before we change the filters, and then one after we changed. And after we changed, the red is always going to be saturated. P2 and P5 forevermore. Very sad. But it turns out it works fine for Venus. The trick is, pretend this is Venus, turn off the saturated red layer. It won't look right because it's saturated. Right-click on your green layer and duplicate it. And then just come down here and color the duplicate red. And it won't look right for has to load back in. And you may have to reset these things. So it doesn't look right for Jupiter, but it works for Venus. You could take the green filter and use it as both the red and the green, and you get something that's white with some yellow in it. I like this here. So Venus will look kind of like this, even if you use the green filter twice. And then with Mars, we didn't get to it, so hopefully we'll do it next time because it's fun because we're at near closest approach. The first one's good, though you have to get rid of the last 9 images because there's a couple hour delay and the planet rotates. So using the first 20 images, it's good. This last one here is good too. And I'll show you one of these just from Facebook. Here, this is the first one using just the first 20 images. I'm getting ready to post something, that's why it won't let me. But the problem with Mars is the brightest thing is not white. The brightest thing is red. So the percentile color combination gives you something that doesn't look quite right. So in that case, what you do is link pixel value and you edit it manually. And I'll show you how to do that next time. So don't worry about that. But if you want to try more Jupiters and Saturns and Venus, this technique works for all of them. You can also use this technique with Uranus and Neptune data. Those planets are blue, their moons are brown, and you get that nice color variation as well. But I'll stop there. Any questions, comments? Okay. And in the module, we talk about the physical meaning of the colors. It's not just, hey, look, there's color, like we did today. But we talk about why Titan is orange, why Io is yellow, the different colors of the gases in the gas giants, what they mean, that kind of thing. All right.
Dan, I have a little bit of an off-topic question, just real quick.
Sure.
Since we're just starting because we have this January term, and so today was our first day of classes. So tomorrow I'm meeting with my astronomy kids who are going to sign up. My question is, we were going to pay for this all through the department. Is it possible to like buy the Cengage stuff like through the department and pay for it, or do I need all the students to like buy it individually?
No, the department can purchase it. Send me an email and I'll get you in contact with the one of my people, or if you're
Okay.
or if you're already in contact with like Cengage's textbook rep, That's fine.
Okay.
But yeah, they
Um,
can do that. Some
okay.
departments are nice and pay for it. Yeah.
The other thing that I want to ask, and this can be for later, but so the course that I'm test running this with is one of my upper level classes, and I think that since there's more advanced students, I might try to run through both curricula. I don't know if that's possible in this in one semester, or maybe that's too much for them to bite off. But yeah, and anyway, that's the thing that I've been thinking
It might
about.
be a little, it might be a little tight.
Yeah. Okay.
It's tight just doing all of MWU in one semester with advanced students. Uh,
Okay.
the Opus they could certainly do. It's easier to do. And they're fun, good activities, and it's orthogonal. One's cosmic distance ladder. This is everything else essentially. But it may be a lot. Yeah.
Okay. Well, maybe depending on how far we get, maybe I'd try to do one or two of them or something at the end, if
Yeah. Yeah.
that's
And you can
possible.
intermix them, whatever you want. Hey, I got to laugh because the radiation from that black hole finally got Christopher. So,
Okay. Thank you for indulging my off-topic
sure.
question.
We tell our students to not get too close to those accretion disks. They'll fry your brain. And oh well. He better be sleeping. If he's actually dead, I'm gonna really regret the jokes at his expense right now. So, anyone else? Anything else? Okay, we'll do some more planets next
Is
time. Oh,
there
go ahead.
is there a module instruction document for this one? Like
Yeah.
you had one for the moon?
Yep.
I think I may have just missed it.
So on the MW sign up page, nope, that's something different. What's the best place to get to all of these? Well, one place with links. I'll put this in the chat. Recently posted a conference proceeding that summarizes the MWU curriculum. It's this one right here. And this has links to all the modules. So this is going in the chat right now. Also, if you're doing MWU with your students, we had the sign up sheet. And that's the Opus sign up sheet. And here at the top, I have links to all the modules up here as well. And if you didn't sign up here, but you just want the modules, I'll stick this in the chat as well. Okay. I'm sure it's listed in many other places. And you have our syllabus here and course plan, which I'm editing as I go. And I can also put in here, maybe the last thing. Sure, this is what I think. Spring 2025 class notes. So these are the notes that I prepare before I go to each class. Highlight this and link it. Okay. Though anything beyond what I've taught, I wouldn't trust the course plan or the course notes. I'm editing these in real time, but the syllabus is good. Oh, and I know we're over, but just a little bit. We have purchased a blogging site. We're testing it with my students, but if it works well, we'll open it up for all MWU institutions everywhere. So instead of just blogging into the individual voids, there'll be a single site where we can all see each other's blogs. Our students can see each other's blogs, and that should be pretty exciting. I'll let you know how that goes. My students have bought it. They told the students to use it. I haven't looked at it yet, so we're gonna see. Okay, if there's nothing else, I'll see you next week. We'll do the other side of planets, the photometric calibration using background stars, and if there's time, we'll squeeze the Mars thing in then.
Thanks, Dan.
Okay.
Thanks, Dan.
Thank you.
See y'all.
Hey, Dan,
Yeah.
Yeah, one thing that I also did for our group, for our especially Opus students, to not get them too wrapped around the Axon Stellarium, is I created some scripts that set it up for Skynet. So you can actually run the script and say, "Oh, I'll set it for Skynet," and it sets all the equatorial mode and the time zone, and so they
Oh,
could
for
focus more on
Stellarium.
the lab.
Oh,
Yeah,
that's nice. Yeah. Yeah. Send me that if you have that. That's
yeah,
great.
yeah. I'll be glad to send them to you. So and then I've also got one that'll reset it back to the standard mode so that but
That's great.
it makes it just they seem to be spending a lot of time playing with that as opposed to
Yeah.
looking at their images. And again, just that's for our 101 students, we kind of noticed that, so we're going to trial that this time.
I didn't even know you could do that. So that's great. And yeah, we'll probably build that in just to make life easier.
Yeah, it's a really easy add-on you can give the students and just tell them to stick it in this directory, and then it just shows up in Stellarium as in the scripts. So I'll send that to you.
Now, if I didn't have to run home, I would just leave this on recording and just wait and see when he wakes up. In our playlist on YouTube, all the meetings are 1 hour, but this is going to be like 3 or 4 hours long.
I'm going to be seeing Chris. I'm going to be up in Raleigh this weekend, so at the astronomy days at the museum.
Okay, yeah,
So
let him know.
I'll be seeing Chris. So
All right. See you
all
later.
right, Dan. Thank you so much.
Sure.